In this chapter, we're looking at right angle triangles and right angle trigonometry. This is chapter 7 in the textbook. So there are 4 subtopics. So we'll have to look at the trigonometric ratios, finding side lengths and finding angles using that, and then true bearings. So first, we'll look at the trigonometric ratios. So these are really important. So if you look at this triangle here, for any right angle triangle, you have 3 properties. You have sine, cosine, and tangent, and that will always be there. So hypotenuse is always opposite the right angle triangle. Opposite is always opposite the angle you're looking for, so in this case theta, and adjacent is neither of these sides, or it's the one closest to the angle, so this is adjacent. So in this case, sine theta is the formula to use is always you can remember as SOH, so that'll be the O stands for opposite and the H is for hypotenuse, so it'll be opposite over hypotenuse. And cos, you can say is ca as CAH, so that will be adjacent over hypotenuse. And then tangent is sine over cos, which if we take these two is opposite over hypotenuse divided by adjacent over hypotenuse, and the hypotenuse will cancel out, so that means tan theta is equal to opposite over adjacent. So using these properties we can solve this example. So we have a right angle triangle here, and we have all 3 sides, and we need to find the angle. We have to find sine theta, cos theta, and tan theta. So to find sine theta, we'll find the angle, we'll go opposite, so this is opposite, and we'll have to find the hypotenuse, and the hypotenuse is opposite the right angle, so this is the hypotenuse, which means that this is the adjacent. So sine theta will equal opposite over hypotenuse, so 15 over 17, which if you put into your you don't need to put into your calculator, you can leave as a fraction. So you have cos theta, which is adjacent over hypotenuse, so that would be 8 over 17, and lastly we have tan theta, which will be opposite over adjacent, so 15 over 8. And if you just do sine divided by cos, you'll cancel out the 17s and get 15 over 8. So that's all for this subtopic. Moving on to using the properties above to find side lengths, we can take a look at this example. So here we have the angle, one side, and we have to find the other. So using what we know above, we know we have the hypotenuse of this angle, and we have the adjacent of this angle, which is x. So you scroll up above, we can have adjacent and hypotenuse, so we can use cosine with the angle. So now just instead of putting theta, we can put 32 as the value. So we'll have cosine of 32 degrees will equal adjacent, so x over 7. So to find x, we'll just use 7 times cosine 32 degrees should equal x, and you can put this into calculator and you should get approximately x is equal to 5.94. So that's the distance of x. So you can use this concept to find side lengths. Using the concept above, we can also find angles. This one is a bit more complicated, but it's quite simple at the same time once you understand. So here I've given a quick example. We have sine theta, and we know that equals 3 over 4. So sine is opposite over hypotenuse, so 3 is the opposite side and 4 is the hypotenuse. So using that, to find theta, we'd have to bring sine over to the other side. So by doing this, the sine becomes sine inverse. So it becomes sine to the power -1. So sine to the power -1 is in your calculator, so there's no calculation you need to do. So you can just put sine inverse 3 over 4 into your calculator, and you'll get theta as 48.6. So using that same thing, we can use this part. You can use that to find the angle of this example. So it's the same for sine, cosine and tan. It all follows the same concept. So here we have, from the angle, we have no hypotenuse, but we have the opposite side and the adjacent side. So we know we can use tan. So tan theta will equal opposite over adjacent, so 10 over 7. So now we have to find theta, so theta equals tan inverse 10 over 7. So you put this into your calculator, you get theta as approximately 55 degrees. So that's it for finding angles and finding sides using trigonometric ratios. Last part of this subtopic is titled true bearings. So true bearings are basically angles. They are measured clockwise from true north and always written with 3 digits plus decimals if needed. So if we look at this diagram, we have a point A and point B. So the bearing of from town A or point A, whatever, would be, let's say this is 48 degrees, so we'd write it as 048 degrees. So the bearing from town B, so town B to face town A, is going to be 228 degrees. So this is already in 3 digits, so we don't need to put a 0. But since north is always facing up, and we always go clockwise, so that's why this way goes like that, and this one goes like this. So that's the concept of true bearings. So we can also use this if they give it in a question combined with the trigonometric ratios to solve questions like this one. So when Sam goes jogging, she finishes 2 kilometers south and 3 kilometers west of her house. Find her bearing from the starting point. So I think it's always better, especially with bearing questions, because they can get a bit confusing, to draw a diagram. So we know she starts off from one point, so we can name that, maybe we'll name the starting point S. And then she goes 2 kilometers south, so we'll go down 2. So we'll say this is 2 kilometers. And then she goes west, so 3 kilometers west. 3 km. So then now we have to find out the bearing of where she started. So we can just maybe draw a dotted line of the hypotenuse. It's because this is a right angle triangle, because she went 2 south and 2 west. And we have to draw the north. So this is the north. So that means north, south is down, and west is to the left because of the compass rules. Okay, so now we can use tan theta. So tan theta equals opposite over adjacent, so we have 3 over 2. So then theta equals tan inverse 3 over 2. So theta equals 56.3 degrees. So this angle is 56.3. So we have to find this angle right here plus 56 degrees. And we know this angle is 180 because it's a flat line. So to go from Sam's place to the dotted line, we'd have to do 180 plus 56.3, which is 236 approximately, or 236.3. So this is the bearing of from Sam's house to the meeting point, to a starting point. Right, so that's all for chapter 7.